It gets hotter than hot. On a cold winter's night here, a wood fire is the most popular way to keep warm, and yet maybe 90% of the heat this fire generates will go up the chimney, and with it goes carbon monoxide, tar, carbon dioxide, unburnt particles and ash. As a way of warming your house, it's expensive, and not just for the fuel. It costs us our forests and our clean air. In a small room at INTI, Argentina's National Institute for Industrial Technology, all eyes and wires are on this, supposedly the most efficient wood stove in the world. It's a multiple combustion stove, which inventors believe will knock conventional wood heating for six in terms of efficiency and environmental friendliness. Designed independently, the prototype has been brought to INTI for a barrage of tests. Firstly, its ability to generate heat. I am being filmed through a thermal imaging camera. At the moment it's black and white, but when we switch it to infrared, all it will see is temperature. This will give us an accurate picture of just how hot the stove behind me can get and how it heats the surrounding air. Judging by the colour scale at the top of the screen, I'm 40 degrees Celsius, while the air immediately around the stove is considerably warmer, 56 degrees Celsius. To look at temperatures inside the stove, we need to rescale the equipment, and it's getting a bit hot for me to sit here anyway. The stove certainly packs a punch in terms of heat generation. The average internal temperature is about 530 degrees Celsius, though it has been known to hit a scorching 1000 degrees. Impressive when you consider a conventional wood fire stays around 300. The infrared camera also shows the distribution of the heat. By changing the temperature range, it can pinpoint hot spots, cool spots, and any areas where hot air is escaping. So while a conventional fire will lose all but 10% of its heat through the chimney, tests here show this stove allows 70% of the heat to radiate into the room. The key to the stove's efficiency is double combustion. Wood is burnt in the first chamber. Hot gases and various particles, like tar for example, that haven't yet burnt, move to a second chamber where they collide with oxygen from outside the stove, allowing a second combustion. This double burning has two big advantages. Firstly, it increases the intensity of the heat. And secondly, it removes nearly all of the pollutants that normally remain and are released into the air. The exhaust gases that leave this stove are closely monitored. For a start, there are less solid particles. The makers claim all the tar burns. The poisonous gas carbon monoxide has been reduced to below 0.1%. This result is 10 times better than other high combustion stoves. And less carbon dioxide is produced because the stove creates more heat with less wood. This stove is 7 times more efficient in terms of fuel consumption than a conventional wood stove. That means your wood pile is 7 times smaller. Great news for the world's forests, Argentina included. 60 years ago, a third of the country was covered in forest. 2/3 of that has gone, mostly up in smoke for fuel. There's a further mechanism for warming the room. Air entering the front of the stove is forced by a fan around a separate chamber between the inner and outer walls. It returns to the room nicely heated. The inventors claim the combustion efficiency of this stove is over 80%, as compared with 10% for a common hearth and 30% for other wood stoves. There's considerable research taking place around the world into more efficient ways to burn wood. A double combustion stove like this, that delivers all the heat you need at a reduced cost to the environment, could make a significant difference in countries where wood is still heavily relied upon for